Good morning. After yesterday's party, once more, good morning. Okay. I'll tell you a little story, and I hope I recite it nicely. I'll just take 2 minutes. Are we all IT professionals? Okay, so not the IT pro versus developers. I'm talking about we all work in the information technology industry. So by the virtue of that, we are all IT professionals. Are you all with me? Yeah. Yes. So listen to this little story, and I think you might know about this, but still. So there's a guy, gentleman, who is away from the city, living in the countryside, and he has absolutely nothing to do with the modern life, the technology, the gadgets, the cloud computing, nothing at all. All he does every day is takes his cattle out, and they graze. He just sits by the tree, watches them. That has been his life, for years. And no one really comes and visits him also. One fine day, he was in his regular life, day-to-day life, and a posh car, or a fantastic car, comes and stops by him, and a guy who is very well dressed, suited and booted, comes out of the car, walks up to him, and asks him, "If I tell you how many sheep you have, will you give me one of your sheep?" Now, this gentleman on the countryside, he is surprised. He said, "Wow, in years, no one ever came up to me, talked to me about anything." And this guy just comes up and asks me a question, and he accepts the challenge, and he says, "Okay, go ahead. Tell me how many sheep I have, and if you are right, I will give you one of my sheep." This guy walks back to the car, takes out his big bag, brings out all his laptop, phones, and whatnot, satellite phones, gadgets, puts it on the bonnet of the car, connects the phone with the laptop, connects to the satellite, takes an imagery map of that area, and all that innovative stuff he does. And within a few minutes, he comes back to this guy, the countryside guy, and tells him, "You have 40 sheep." And this guy is surprised. He actually has 40 sheep, and he is amazed. And he is, "Yes, you are right. I have 40 sheep here." He says, "Wow, then I'm right. Keep your promise. Give me one of your sheep." And he hands over one of the sheep to this gentleman from the city. While he's going back, this guy from the countryside says and asks him, "If I tell you who you are, will you give me my sheep back?" Now, this guy from the countryside, the city, is amazed. He's surprised. He says, "Okay, I accept the challenge. Tell me who am I, and I will give you your sheep back." And this guy from the countryside says, "You are an IT professional." Well, the story is not yet over. So this guy from the city says, "Yes, you are right. I'm an IT professional. I mean, amazing. How did you know that?" He said, "Well, it's very simple. There are 3 basic rules. First, you are uninvited." So the first rule, you are uninvited. Second, I didn't have a problem and you started giving me a solution. And the third, you know nothing about my business. Now give me my dog back. We are still IT professionals, right? Yes, we are. We are proud to be that. Okay, good morning once again, ladies and gentlemen, to my session, Baselining and Benchmarking Always-On Availability Groups. I am here because of you. In previous Microsoft conferences like TechEd in the last years, I have been trying to bring a lot of innovative content to Microsoft conferences, and fortunately, I got a lot of good feedback. And this year, again, Microsoft asked me, "Do you have something to present?" And I said, "Yes, I have some really nice content." And he said, "Okay, so fly over thousands of miles and come over and deliver the content." So it's really an honor and privilege to be standing in front of you and delivering this session. So I have come all the way from India. I am from India for Microsoft Ignite. I make no mistakes. I was about to say TechEd 2015. So yeah, thank you there. Quickly, about me. I work for SQLMaestros.com, working there as a director. I am also a Microsoft Certified Master of SQL Server and a long-time MVP. And by the virtue of doing a lot of good work around SQL Server and the community, Microsoft honored me with the regional director status for the APAC region this year. And by any chance, have you come across SQLServerGeeks.com? Yeah, sometimes? So I founded this community site way back in 2010. And we have a lot of content there. We share blogs, videos, podcasts for the community. That's my email ID in case you want to reach out to me after the session, amit.bansal@sqlmaestros.com, and my Twitter handle, _Bansal. So why am I here today, and what are your takeaways from this session? So this session is actually based on a proof of concept that we implemented for one of the largest banks in India. And it was a challenge which was thrown at Microsoft, and I'm going to talk about the business case and how we implemented it, what were the challenges that we faced. So your takeaway the first takeaway from this session will be, can always-on availability groups be used for solutions other than HADR? All of you are familiar with always-on availability groups? Yeah? And all of you know this is one of the premier solution that you can have with SQL Server for HA and high availability and disaster recovery. But can you use it for something else? And this is what I'm going to talk about. Beyond that, I will talk about the strategy, the tools, the techniques, the scripts that we deployed to benchmark and baseline always-on availability groups. And note there, I've highlighted SQL Server there because today, the content that I'm going to deliver to you can be used not only to baseline or benchmark AG deployments, but in general, you can use it for a normal SQL Server deployment also. So please keep that in mind. Don't always think in terms of AG groups. You can always take this content and think in terms of general SQL Server deployment. So there were a lot of challenges that the customer had thrown at us, and I'm going to talk about these challenges and what exactly did I do when these challenges were given to me, and how did I do it? What I did and how I did it is very important because when this customer threw these challenges at us, Microsoft India knows that there's one guy in India who is actually ready to jump from a plane at 25,000 feet without parachute, and that is me. So when they are such challenges, they call me in and they ask me this time, hey Amit, are you ready to jump again? I said, yes, why not? And then we implemented this. The overall our collective object here will be to get a very good head start in benchmarking technique. A lot of us talk about baselining and benchmarking. There are a lot of theories around it, but practically speaking, and let me do a show of hands, how many of you have actually implemented a full-fledged benchmarking or a baselining technique, or you've performed such an activity before you go and do a massive deployment? Anyone here? Okay, great. Yes, Bob, I would know. Yes, so we just have very few people who have done that here, and I'm going to talk about this, how we did it. So the business case was as follows. One of the largest banks in India, top 3 banks, used a local vendor's XRM platform. That's just an extension of CRM, XRM platform, and this was running on SQL Server 2008 with Windows Server 2008. I'm trying to keep things simple. This deployment was done on IBM servers, high-end IBM servers, and the server configuration goes something like, we had 2 40-core motherboards that were fused together using IBM planar technology. And they also had somewhere down in the corner storage area network, which actually housed the data. The concurrent users were approximately 5,000. This was the current situation that the bank had. And how the situation actually unfolded was the bank witnessed consistent and unprecedented growth in their user base. And they did an estimate that in next 3 years, our concurrent users might increase up to 15 to 20,000 users, or even 25,000 users. Yes, welcome to India. And when we talked to the business leadership of the bank, and they said even 20 to 25,000 concurrent users is a conservative estimate. So the challenge that was given to Microsoft was, hey, Microsoft, go ahead and prove a scale-out solution on SQL Server, and prove to us that you can scale up to 20 or 25,000 users on commodity hardware. That was the challenge that was given to Microsoft. And we also had to, sorry, I jumped a little fast. So we also had to meet the performance SLAs for these many users. Before we actually started using or testing this kind of massive configuration on SQL Server, there were a few alternatives that the vendor, the CRM vendor, the bank, and Microsoft considered together, which were as follows, but none of them were so very practical. The first one was, by the financial institution itself, to switch from a local vendor to a global CRM vendor. This was definitely too disruptive and too expensive for the bank to implement. They considered the second alternate, which was switch from a relational database technology to a NoSQL technology. And this was some brainy thing that someone from the customer side tried to do. But this, again, is a very non-trivial design and a completely different technology altogether. The third, which was a little probable alternate that was considered, is add another motherboard of, say, 40 cores to the current setup and configuration. But IBM engineers explained to the customer and to Microsoft that we will have diminished returns if we try to do something like that on planar technology. So the solution that we moved ahead was with SQL Server, and we used SQL Server AlwaysOn availability group. Now, this is interesting. How did we actually use AlwaysOn availability group to meet the challenges of this requirement? So let's quickly get a quick overview of AlwaysOn availability group. And I assume that many of you already know and have been working with this. So you have two nodes here that I display on the screen. So you have node 1 and node 2. And node 1 is configured as the primary replica. Node 2 is configured as a secondary replica. Availability groups is a successor to database mirroring. And the idea here is to implement a HA or a DR solution with AG groups. Your data is constantly being shipped from your primary replica to your secondary replica. The secondary replica is a complete copy of the primary database. When the data moves from primary to secondary, there are essentially two ways on how you can synchronize the data. You can use synchronous commit mode, which means a transaction has to be committed in the secondary as well as in primary before a commit acknowledgement can go to the client. And as you can understand, that may introduce a bit of latency. The asynchronous mode is the transaction is committed on the primary, acknowledgement goes to the client, and then behind the scenes on real-time basis, log records are going to be shipped from primary to secondary. There are those chances of data loss in that scenario, but then you do not degrade on performance in asynchronous mode. And if you have worked with availability groups, you would know that asynchronous commit mode in many cases works much better than synchronous commit mode. But this has to be decided by the business. The secondary could be non-readable or it could be readable. And if you go back in the early history of SQL Server database mirroring, the mirror server was non-readable unless you create snapshots, etc., which were some workarounds. But now, starting from SQL Server 2012, the secondaries can be readable, and you can have up to 4 of them. So that's a very quick, high-level overview of availability groups. So what did we do here is we had not actually used availability groups as a HA and DR solution. Our requirement was to scale out, and we implemented something what we call as load balancing. Load balancing between the two boxes. And what we thought we could do something like this is on the primary replica, we can have read and write workloads. All our DML operations, like inserts, updates, and deletes, will go on the primary node, and all the read operations will go on the secondary node. Now, going by any business, every business would have some ratio of read-write versus just read-only workload. And this is how we plan to scale out because our requirement was to prove to the customer that we are scaling all the way to, say, 15,000 or even 20,000 users. However, there was one tricky thing here. was, what do we do? Shall we implement synchronous commit or asynchronous commit? Now, knowing the fact that this was a financial institution and they have been used to always seeing real-time data, the first set of benchmarking that we did, we went ahead with synchronous commit because, and that depends on customers. So it's not necessary that you would do the same thing in a financial institution. You may work in any other vertical, manufacturing, retail, so on and so forth. But for this financial institution, the bank, it was important that we do it in a commit mode so that they see real-time data across whether they read from primary or from secondary. So this is just to let you know. And I will digress a little more into this. This was our strategy on how we wanted to perform this baselining and benchmarking activity. So let's look at the setup now. We set up 2 boxes in IBM data centers. These 2 boxes, so the one was, and we connected both the boxes with a 10 Gbps network. These boxes were configured with SQL Server 2012 running on top of Windows Server 2012. The configuration of both the boxes were more or less similar. If you see, primary had 128 GB RAM, and the secondary had 96 GB RAM. And the difference in number of cores were about 6. So the primary had 32 cores, and the secondary had 24 cores. Now remember, this was the test hardware that was given to me. This was not the actual production replica. It was the test hardware, because the production boxes were like 80 cores and 96 cores. And of course, we had to set up AlwaysOn availability group. So we needed a domain control, because one of the prerequisites for AG groups is we need to set up Windows failover clustering services, and AG sits on top of it. So we set up the domain controller, and then we configured Windows failover clustering services. Somewhere in the corner, we had storage area network. To be very precise, this was IBM StoreWiz V7000 model. And the SAN guys created one pool, 6 volumes, and gave me like 300 GBs per LUN for 3 specific sets of data, which was the data files, the TempDB, and the log file. And I tried to get dedicated LUNs and dedicated spindles behind those LUNs, because I knew we wanted to get the best performance out of this deployment and this benchmarking. So the data, log, and TempDB were set up both for the primary as well as for the secondary. And we configured RAID 10. And this SAN, if you know about this model, it's based on SSDs. So it has, you can put like hundreds of SSDs into this SAN and make it a big pool of SSD storage. There was a bit of conflict between RAID 5 and RAID 10, and I'm going to digress that a little later. We connected the boxes with the SAN using all the necessary networking equipment, and primary replica and secondary replica was configured, and AG was set up. This was the basic primary setup that we did, and then we also needed some servers from where we can fire workloads for our benchmarking and baselining. I was originally given 1 server, and I was thinking 1 server. Think about it and let me know what your opinion is. If from 1 single client, and I'm firing, say, 15,000 user requests, would it really work? Maybe not. Practically speaking, you will have hundreds of clients spread across various geographical network. So what I did, I went back to IBM and the customer. I said, I at least minimum need 4 servers. And I took 4 physical boxes, and I set up 4 VMs in each of these boxes. And I simulated 16 clients, and I distributed the workload across these 16 clients. Now, this setup itself is not an ideal setup, because if you talk about 4 VMs on a single box, I'm actually choking the network, because these 4 VMs are sharing the same network bandwidth that the physical box has. So a little bit of relief I had, because I got from 1 to 4. But yeah, given my flexibility, I could have even taken more. But that was not just made available to me, so I had to go with this. And then all these 4 clients fired workload on the SQL setup. Any questions this far on the setup that we did? Are you all with me here? Yeah? OK. And then what were the tests that we performed? There were primarily 4 tests that we performed. First, I performed an I/O test, followed by what we call as the breakpoint test, which was SQL Server 2012 breakpoint test without any always-on configuration, and then we performed always-on synchronous commit mode test that was in synchronous mode without reading the secondary. And the last test that we performed was synchronous commit mode with readable secondary. These were primarily 4 tests that we performed. Now here, friends, the meat of the content beyond this is, forget the bank or the scenario that was given to us or the industry or the vertical. What is important is the technique. How did we do this? And you can just take this technique and replicate it for any given requirement. So let's first talk about the I/O test results. The SQL I/O test results, I did RAID 5 and RAID 10. Now, just asking you from your experience, which one do you think would have performed better? RAID 10, of course. Why did I really go and do RAID 5? If we know RAID 10 will definitely perform better in a SQL Server deployment, RAID 5? Cheaper? More spindles? Okay. SAN guys forced it on me. Because the current setup was running on RAID 5, and I was told we will go with RAID 5, irrespective whether you do your test on RAID 10, we will still go with RAID 5. And it was my job to prove to the bank that you're talking about huge performance numbers, so you need to give me best hardware and best setup. And to prove my point, I did RAID 5 test and I did RAID 10 test. And if you were interested, I have the test with me, the raw data with me on my laptop, and after the session, I can share those the files with you. So you can see I ran multiple tests. And I used a tool called SQL I/O, and I'm sure all of you are aware of it. It's a free tool from Microsoft. Even though the tool says SQL I/O, it has nothing to do with SQL Server. It's a raw testing tool. If my understanding is correct, it was built by SQL Server team, and that's why it's called a SQL I/O. It's a command line, very straightforward command line tool that you can use to test the raw disks. And here are the numbers for your perusal. If you look at the basic 4 tests that I did, random read, random write, and the last 2 rows, sequential read and sequential write. 3 important metrics that SQL I/O tool will give you in the results. And if you look at the metric column, starting from IOPS per second, which is how many input-output operations that happened, and megabytes per second, which is the throughput, and the average latency. So for each type of test, we got these 3 metrics, and these 3 metrics across RAID 5 and RAID 10. And if you look carefully on the last column, which is gain %, and just look at the first row under RAID 5 and RAID 10, you can see 173% gain that we got on IOPS per second. So approximately 15,000 IOPS in RAID 5, and approximately 27,000 IOPS on RAID 10. And you see consistent improvement even in throughput. So which was the next row, you will see 122 megabytes per second versus 213 megabytes per second. And look at the latency factor, and we got an improvement of 3 milliseconds on the latency. Now, these were very critical numbers to prove to the customer that we need RAID 10, because I wanted the best performance out of the disks. And this was all about transactional throughput, a banking environment. You're talking about 20,000 users reading, writing, and you want the best throughput from your data files, from TempDB, and definitely from the log file. Another important thing I want to tell you in this test is when you use SQL I/O test, you can test with different data sizes, which is like 8K, 16K, 256K, 512K, etc. I omitted the tests with 32K or 16K for that matter, because my focus was on transactional throughput. And transactional throughput with SQL Server reading and writing in a normal way is all about 8K pages. And I kept my focus on that, which means I was not really interested in testing some ETL operation or backup restores, which uses higher or bigger I/O chunk sizes. So I kept my focus on 8K. Just to show you the raw file in a moment. Is it on screen? No? Okay. I don't get to see it here. Okay, anyway, so if you are able to see, here are all the numbers that we get, IOPS and throughput, and you will see simple SQL IO test that we ran. And one of the parameters, I'm finding it a little difficult to see on the screen there, but will be block size 8. Is that there somewhere? Okay. Yeah. And this is your random read and number of threads outstanding. And this is a simple test that we did. And of course, we did multiple iterations of this particular test. And I will, if you are interested, I can always talk more about this after the session. Another important thing is when you are doing a SQL IO test, please make sure that the file size that you create for the test is at least twice the size of the SAN cache. So suppose the SAN cache is, say, 64 GB, your test file size should be at least 128 GB. Or else what will happen if it is smaller, you're not going to test the disks, you're going to test the cache. Some really basic rules and some best practices is what I followed, and these were the numbers. So I proved it that we want rate 10, and we went ahead with rate 10. That's the summary of the IO test that we did. Now, challenge number 1. We did the IO test. The setup was done. Okay, all convinced. SAN guys put up rate 10. Customer was happy with rate 10. The first challenge that we got was the test data real? What do you think? Was the test data that I used was real? No. So the financial institution, and I think this is how it will work globally, they refused to give me their data for testing purposes. So the next question the challenge that I had was, okay, was the test data realistic? Now it's important for me to make the test data realistic. Or do you think with real world benchmarking and baselining that we do, can I take AdventureWorks, Pubs, and Northwind? Not really. So I have to use test data that is realistic. And how did I do that? So yes, the test data was realistic. How did I do it? We can get banking schema from World Bank organization that is publicly available. Or you could use sample schema and data from data.gov, right? Just download the schema, download some sample data. That is what we did. And through scripts, we generated test data on that schema, and we inflated the tables. So what we did, we created, using that sample data and sample schema, we created a few hundred gigabytes of data for the test data. Because it's very important that when you're testing, you use realistic data for that particular domain. Just trying to make it as real as possible. That was challenge number 1, and this is how we overcame it. Challenge number 2, read-write ratio. Now, everyone talks about industries and verticals. Okay, banking domain or financial institution. So they will probably have 70% read and 30% read-write. 70-30, maybe. 60-40, maybe. 65-35, let's go for it. The idea here is no one knows what the read-write ratio really for a given customer is. It's very difficult to find that out, and you have to only make assumptions by talking to the customer. If I'm not even given the opportunity to run SQL Profiler or anything on the server to just really get the pattern of data, it's very difficult to figure this out. So I engaged the customer here, and I said, OK, we will go with, say, 65-35, or maybe even 60-40. That was the challenge number 2, which is the read-write ratio. Challenge number 3 that I had was the read-write pattern. What do you mean by read-write pattern? How are these users actually reading data? How are these users writing data? And to understand this, and to replicate or simulate this, I need to have domain experience. Unfortunately, I'm not from financial background, so I'm a SQL Server guy, and I don't know anything about how banking works other than checking my bank balance. So I had to engage the business here. And if you have domain experience of the customer you're working for, it's an advantage on your side. Or else I engaged the business. And what I did, I engaged the business, and I sat with the users to understand what exactly are they reading, what exactly they are writing. So simple things like running a query to find the bank balance of a particular customer number, right? Running a query to find the last 10 transactions, right? Or simply updating the customer account with a new address or a new phone number, or entering know your customer information details. After understanding the read-write pattern, I drilled down and created 5 different read type workloads and 5 different write type workloads. Now this was to me, I think, in the entire benchmarking and baselining activity that we did, was one of the toughest pieces to actually replicate those workloads and generate scripts. So type 1, type 2, type 3, type 4, and type 5 for the read, and similarly for write. Are you all with me on this? Yeah? Any question there? Oh, OK. And then, if we go to the workload, look at this massive scripting work that we had to do. If you look carefully, there are 10 command files there, right? Starting from read type 1 all the way, read type 1, 10, 20, 30, 50, all the way to 100. Each command file, if I double-click, will simulate those many users. So if I double-click on read type 100.cmd, which is the third last file, it will spin off 100 users who will fire read type 1 workload, right? What is the command file going to do? This command file is actually, all these 10 of them internally will call a PowerShell script. This PowerShell script is going to randomly pick up a read type 1 workload from my read type 1.sql file, which I showed you on the previous slide. So my read type 1.sql will have a lot of read type 1 workload. PowerShell script will randomly call a query, and I will show you that script also in a moment. And those many users will be spun off. This was a lot of manual activity that I had to perform. Now, friends, think about it. Baselining and benchmarking could be very easy. You just get a test tool and like Aura Hammer, or you just download a test stress tool and just create a few scripts and just fire them off and set, you want like 100,000 iterations and you want like, say, 10,000 users. But that's very fluffy. That's not how baselining and benchmarking has to be done. In order to make it realistic, you will have to have these kind of scripts where you try to simulate the customer workload. And this is how we simulated customer workload. And this was for read type 1. We take all this data and we put it into our called read type 1 folder. And as you know from the last slide, we had 5 different read type workloads. And we created 5 such different folders. This was for read type 1. And similarly, we did this for write type. So if you see all the highlighted folders there are write type. Each one of them will have necessary scripts scaling from 10 users to 100 users. And I will launch them, and I will fire them from my VMs. Yes, question? So it was a mix of stored procs and T-SQL statements. Very good question there. Was it all stored procs or T-SQL statements? It was a mix of that. And this was, again, an information knowledge that I got from the customer. I just didn't get to look at their queries, T-SQL, or stored proc. So I used a mix of them, like a serial one, noisy neighbors. I created all sorts of things in these scripts. OK, let's move forward. So the workload was created, and this was a very daunting activity, to really put it honestly to you. And this was the PowerShell script. It's just a prototype of the PowerShell script that I created. And if you look in, we simply, one of the things you will focus on the third line, look at the content delimiter there. I just used a few dashes. So in my read type 1 SQL, all my SQL file, I have these bunch of queries that were separated by this delimiter. And my PowerShell script will randomly call a script inside my SQL file and launch them, right? Depending on the number of users that I fire. So that's how we did it. There's another interesting aspect to this PowerShell script. If you look at the last line, the last piece of code there, which says start sleep milliseconds 100, which means when it is running in a loop, between every execution, there is going to be a pause of 100 milliseconds. I'm going to digress a little more about this in a moment. But that's very important again. What we did, so we had the setup. The only missing piece in this setup was to deploy the workloads, and the workloads were deployed on these boxes. And then what we did was firing them from the VMs. This was absolutely manually done. I did a bit of automation here also. So there was another master command file, which used to call the 10, 20, 30, 40 command files. But that's not important. That was more for my convenience sake that I did that. When this was going on, what was I doing? I was monitoring. So I was using all native tools like the task manager, the DMVs, and the performance monitor. And that is on the side is just a screenshot of my performance monitor window on some of the numbers that I was constantly watching while the workload was going on. All this while, if you see, I've not used any third-party tool here. Everything that we did was native, right, with T-SQL scripts, DMVs, etc. The moment this workload started, I hit my next challenge, which was challenge number 4 on SQL Server max worker threads and cost threshold of parallelism. Now, this is super, super critical and very fundamental to the baselining and benchmarking activity that you will perform. And now I will switch to a demo to digress a little more into this. OK, I need some help. I'm not able to see. OK, I have to stop extended monitor. Is that OK? All right. Thank you. Now, friends, so there was a lot of theory there. Now we are coming to a little bit of action, and I want your attention, because this is the core meat of what we are going to do. My question to you is, 15,000 users, would it mean 15,000 threads for SQL Server? Could be more, or could be less. Not necessarily the same number of threads. If I look at max server threads now for SQL, max workers count, I get 576. Is the output and font visible on the back rows? Yeah, I get 576. Where is this number coming from? This number is coming from a simple formula here. If on your server you have logical CPUs greater than 4, then max worker threads is 512 plus the number of logical CPUs that you have minus 4 into 16. If we apply, so this is where we get this number from, 576. How many threads do I have on my laptop right now when I'm running this demo? I have 8 cores, right? I have 8 cores. And if I apply this formula for 8 cores, I get 576, which means the formula is correct. If I take this formula and I consider the production box, which had 2 motherboards of 40 cores each fused together, giving me 80 cores, and I check this with 80 cores, I will get max worker threads of 1728. Now, what do you mean by max worker threads? This max worker thread setting in SQL Server means that at any given point in time, SQL Server will not go beyond approximately 18,000 threads, right? So the thread pool that SQL Server will not have more than 1,800 threads. Now, let's think a bit. How will 15,000 users, concurrent users, satisfy their read and read-write request with just 1,800 threads? So I'm sure we all are thinking that we have to increase this threshold, right? We have to increase max worker thread threshold. But before we do that, let's digress a little more, go a little more deep into this. If I look at number of sessions right now, I have 50 sessions, and number of threads right now that I have on SQL in SQL thread pool is 99, right? When I create, if I open a new session to SQL Server, I click on new query here, I opened a new session, and when I look into my sessions and threads, you will see the session count increased to 51, but number of threads remained to 99. Now, this particular session, session 58, is an active session with SQL Server. Are you all with me? Yeah, it's an active session to SQL Server, but it's actually not consuming a thread because this particular session does not have any active request. It's just an idle session. To prove this, I can actually check. This is session 58, and I replace this with session 58, and I check, do I really have a thread for this session? No, I don't have a thread. Which means, friends, what does it mean? When my customer says, OK, prove a scale-out solution to me and scale up to, say, 15,000 users, does it mean that all 15,000 users are constantly doing something? Not necessarily. Many of them might be just sitting idle. They might have an active connection with SQL Server, but not necessarily consuming a thread. Well, the customer would not be so stupid to be fooled that we launch 15,000 connections and they're not doing anything, because we need to show them the workload also, and that workload will be shown by batch requests per second. All of you know this counter, batch requests per second? That shows you how fast your SQL Server is and what is the transactional throughput. But now, if I open up a small workload here, and let's fire this for a moment. Now, this is 59. Let me take this script and put it into 58. And let's just simply run a while loop, which is constantly running. And I look into this. And now you see there is a thread, right? Because there is an active request going on. Is it making sense? So for that one session, we have one thread. But if I stop this, and for example, the business requirement changed. They wanted all the data from a table, and then they said, OK, my requirement changes. Can you order this data by line total descending? We said, yes, let's do that. And I run this workload in a while loop. And now when we look into this, what's going on? Let me go and stop this. This is really a chicken and egg situation to talk about max worker threads and this particular thing. What do you think went on now? We see 9 threads, right? We see 9 threads for that workload. And in the previous instance, we saw just 1 thread. So all of us can understand here what's kicking on. Parallelism, right? So this particular workload, the second one that we ran, where we ordered the data, for the SQL Server Query Optimizer, when it considers the cost threshold, it considers the parallel plan to be less costly than the serial plan, and it outputs a parallel plan. And that request is parallelized on all the cores that I have. So I have 8 cores, and the request gets parallelized on 8 cores, and I get 8 threads. You see 9 threads here because there is one controller thread. You call that controller thread or a main thread or a parent thread, whatever you feel like, but that's the parent thread. If I look into the execution plan of this one, just to prove my point here, I select this and turn on actual execution plan and execute it. And look here, and you will see parallel indicators. Does it make sense? And let's say, look at a clustered index scan operator, and if you go into F4, into the properties, and you will observe that we had 8 threads starting from 1 to 8, and this is the 9th thread, really, which is the first thread, is the parent thread. Now, friends, why am I showing you this? This was super critical to the baselining activity that we did. Why? Because the workloads, then the scripts, read type, write type, all that I created, and if I had 80 cores on my box, and if all my read workloads are parallelized, for each request, I will get dozens of threads. Which means if I get dozens of threads for each read workload, I will immediately and quickly exhaust my max worker threads. Does it make sense? Yeah? This was something that hit us immediately. And it took me a while, though. Now, friends, the session is not about SQL internals or about SQL OS. Bob is laughing, right? It is fundamental to the benchmarking that we did. So we get a sense here that if all these workloads are getting parallelized, we will hit max worker threads quickly. And the most important thing that we need to understand here is not all workloads need to be parallelized. I practiced a lot saying parallelized. I have difficulty pronouncing parallelized. And you know, don't mind, but in India, where we say, I tell the audience, if I say paralyzed, it's equal to parallelized. Becomes easier for me to pronounce, becomes easier for the audience to understand. But probably you might not permit me to do that here because the session is being recorded. So I will have a hard time saying parallelized. Okay? So what am I trying to talk about is, let's look at this one. What does this statement do? Max top 1. It forces the query to run on a single core or on a single thread, right? Max top, max DOP. When I run both of them, the first one says, optimizer, do whatever you want, and the second one, force it on a single core. And when I execute, and I look into the execution plan, okay, do you see that? That's nice, because the second workload did not run, 100 versus 71. Okay, that happens because the results sets were still coming. Now you see, what do you see? 29% versus 71, right? So of course, SQL Server knows that the first one where it actually parallelized the query is faster in terms of cost versus the second one where I forced a single core. Now, if I change this to max top 2, just keep looking at the difference. Oops, sorry. And if I change it to max top 2, I need to get all the data in a moment, and I go to the execution plan. We get 38% versus 62%. Are you all with me? Do you see we are closing the gap? Which means if I make it max top 3 and then run it, I will close the gap even further. And this time we get 45 versus 55. Okay? And finally, if I make it max top 4, and you will be surprised to see this, that we actually come close, I mean, identical in terms of performance of the execution plan, which is 50% versus 50%. Which means if I go by the optimizer cost threshold, this query can perform equally good with 4 threads, not necessarily 8 threads. That's the point. Not necessarily 8 threads. Are you all with me on this? Now the point, the decision that we had to make here is, do we really have the flexibility to go and put an option max top with so many different types of workloads? No, we don't. Neither in real world and nor in the benchmarking and baselining that we do. So we can't really actually go and put option max top and try to manipulate that. It's just not possible. So what we have to do is we have to simply increase the cost threshold of parallelism. So this is a SQL Server configuration where the default value, I think, is 5 for this one, and we have to increase it, right? So every plan has a cost. And if you want to look at the cost of the plan, you can simply go to the execution plan here and hover over the select operator, and you can see that the cost of the plan is, say, here, 4.3, right? And if I increase it to high value, what will happen? By default, a lot of workloads will not be parallelized. Okay, this is how we have to play it. Friends, given the sense that this also is not the best thing to do, I mean, from a realistic testing point of view, but at least it comes closer to what the real workload would be like. Okay, so we had to. So there were 2 things here that I did in terms of configuration setting. One is I changed, as a starting point, I changed the cost threshold to 50 so that these requests that are coming from the client, all of them necessarily need not be parallelized, and they will just use 1 thread. Okay, that was one of the things that we did. And of course, some expensive queries which had like complicated execution plans and genuinely should be parallelized, they will be parallelized. Now, this is a number that you can fine tune, 50, 45, 60, depends on your workload, depends on your environment. And max worker threads. Now, by default, you see max worker thread is automatically calculated starting from SQL Server 2005 based on the number of cores that you have on the box, as I showed you with the formula. But again, we have to change it, and I change it to something like 30,000. This is not a best practice. Remember, with warning, with caution, max worker thread is, you should just not change it in a normal circumstance. If you have a lot of different performance issues, specifically with respect to thread pool weight types or thread starvation situation, then with due consultation with Microsoft support engineers, you may want to change this, but not really. So these are not the things you will go and do on your production boxes. Okay, so a bit with warning there. And if I go ahead and change this, okay, so I need to turn on advanced options. These are all advanced options. I change this, and I change the cost threshold, and I change max worker threads. Boom, we are done. And now, if I look at my max worker thread count, it's 30,000 now, which means I can really hit the ceiling of 30,000 now. I will not be limited by 1,800 threads, because I know I'm going to scale up to 15,000 users, so I might just need those many threads. You can play with this value. We set the cost threshold to 50, which means now this particular query, by default, which was being parallelized, will now run with a single thread, and you can see it's a serial plan that you get, right? Another piece with this, and this is a very common mistake that I see SQL Server professionals do when they forget about this massive baselining and benchmarking activity, but I mean simple baselining benchmarking work or just running scripts in a loop to just do some stress test is this. And I want you to be very careful with this. If I open my third script, and just to show this to you quickly, and let me close all other people here. Friends, are you enjoying the session? Yeah, is it interesting? Okay, great. Well, it's a kind of an uncommon session, not really talking about any feature or a new functionality. It's just something innovative that we did. Now, this is a common mistake that we do. What is this common mistake? Look at this. So we go to AdventureWorks database here, and I fired this as a batch. Okay? Between two statements here, I put a wait for delay. Because when you do stress test, now 15,000 users, friends, they're not constantly going to do read-write activity, isn't it? Are all 15,000 users going to be like while 1 equals to 1 do something? Obviously not. They're going to connect. They're going to fill out some form, which is what we call as key in time. How much time do they take to fill out a form, say, if they're doing an insert operation? Or the think time. They're not going to be, users will not be as smart as you have 15 fields, just go and quickly fill everything. They will probably think before filling out something. So that is what we call as a key in time and a think time, which means while these activities are going on, there is a delay. Will you configure delay this way between your statements that you fire? You know, the problem if you do it this way will be, this statement will fire, and then you do a wait for delay, say 60 seconds, just to simulate, or 30 seconds. What is going to happen? Let's take this. This is thread number 59, and I replace here session number 59, and I run this, and I test. Can anyone explain what's going on? This is waiting, right? Because we've put a wait for delay, and you see a thread here in suspended state. From the baselining and benchmarking activity that I'm demonstrating, what does it mean to you? While the user is thinking or while the user is keying in, the thread is blocked. Are you getting it? The thread is blocked. Thread need not be blocked. User will do something, take the thread. So this is how it works. Connection, session, right? Session will fire requests, which you can see from DM exec request. Requests will be converted to tasks at SQL OS level. Tasks need to be performed on the CPU. So a worker will be there in SQL Server, which will spin off a thread from the thread pool, take the task, and schedule it on the scheduler. And when the job is done, the thread is going to be returned back to the thread pool. This is how it works inside SQL Server. You can't block the thread like this. Why? Because the user is just not doing anything, and the thread is blocked. Again, the problem will be, I will hit the thread starvation situation. And that's the reason why we used PowerShell as one of the techniques. And in the PowerShell, when scripts were being called in loop, we had that delay of 100 milliseconds. You remember the last line there? Which you can configure, 100 milliseconds or 1 second or up to whatever your workload is. So really, you see, this concept of max worker thread, parallelism, workers, threads, task is very critical when you want to scale up to so many users. Any questions on this? Are you all with me on this one? Yeah? Great. So let's switch back. Is the slide up? OK, great. So that's what I did. Cost threshold of parallelism is 50, and the max worker threads is 30,000. Of course, these are numbers that I played around with, and in your environment, these numbers could be different. Are you ready for the results? Yeah? And if you like, you may applaud. So the first, I truly appreciate, because you're applauding without even looking at the results. So did we really scale up to, say, 15, 17,000 users? Friends, here is the real graph for you. The first one, user connections versus processor utilization. And look at that ceiling, 17,000 user connections. Now you can clap a little more loudly. And this scale happened. Friends, really, this 1 hour is so short because there's so much that I want to talk about when we did this activity for one of the largest banks in India. It was a test that we did over 8 hours. Each test, and we did multiple iterations of it. If you look at the time on one of the axes there, the scale out actually happened in approximately 1.5 hours. Scale out here is not like you double click something and boom, from 0 to 20,000 users. No. You had to do it crafted slowly. We scaled out in 1.5 hours. And that's why you see that graph. So if you see the beginning of the graph at around 4,000 there, it was very easy to quickly jump to 4,000 or 5,000. I mean, SQL Server was able to do that quickly. But then beyond that, it takes its own time for the engine to scale out these many workloads. And then we had the processor utilization. So this was the first test result without any always-on configuration. This was simple breakpoint testing. Now, breakpoint, you may ask me, what happened, Amit, beyond 17,000 users? SQL Server stalled. Yeah, I mean, there's nothing to shy about this, because that given the hardware configuration of 32 cores, that was the max that we could go. And beyond this, it was just not scaling up. It was just not going. That was the ceiling we hit with 17,000 users. And then, yes. Oh, no. So yes, so no, SQL Server, by stalling, I mean SQL Server will not stop. Obviously not. All the users that are connected and they're randomly firing workload, all that will execute. It's just that new threads are not going to be spun off. New users will not be able to connect, right? And if I go and look into wait types, I will see a lot of these different wait types and thread pool, etc. This is just one of the graphs that I'm showing it to you. There were dozens of them, and there were a lot of metrics behind it. So I captured all of that information, again, using all the native tools like perfmon counters. This is all from perfmon, and we put it into Excel from where we built the graph. The next one, which you would be interested in seeing, well, you had 17,000 users. How many batch requests did you really have on per second basis? So if you look at that threshold, we had approximately 7,000 batch requests per second. This was a very good number, given the scale out that we did. And of course, processor utilization was always around 80 to 90%. Then comes our next test, which is always on synchronous commit mode. So the previous two graphs, yes. Technically speaking, I hit the limit on threads. Yeah, well, to be honest with you, really everything maxed out, right? But if your question is, where did we really stop? You know, what was the main bottleneck where we stopped? We just could not go beyond those many threads. Suppose if I had configured 30,000 threads, I was just not scaling beyond it. And let me also digress a little more deep. If I wanted, I could have even gone beyond 17,000, but business did not ask for it, right? So there's no point in going beyond or doing something that business is not asking. So when I hit 17,000, that's job done, at least in the breakpoint test. But our idea was to scale out on always-on availability group, right? That's the meat. So I'm coming to that. Then we did SQL Server 2012 always-on synchronous commit mode. Sorry, yes, question. Okay. Query response. I can show you those numbers after the session. Yeah, there are many of those numbers, so I will love to chat with you on that. So always on synchronous commit mode, if you see, what was the difference between this test and the other test? Well, very simple. This test was when we configured AG groups, which means now we have the primary replica and the secondary replica, and primary replica is shipping data, the log records, to the secondary replica in synchronous mode. The numbers are going to be similar because we were only hitting the primary workload. We did not hit the secondary replica at this point in time. So you will see, again, 17,000 users approximately, and close to 7,000 batch requests per second. And then comes readable secondary. Now, this is what we wanted to prove to the customer, that not only 17,000 users or 20,000 users with always-on availability group scale-out model, you can even go beyond 20,000 users, because we are talking about one readable secondary. You can have multiple readable secondaries, right, in AG. And I think in SQL 2014, we can have up to 8 readable secondaries or so. Yeah, 8 or so. So if you look at with readable secondary, now I'm looking at my primary user connections versus processor utilization. And I stopped at 7,000 users. Why? These were my read-write users. They were hitting the primary workload, correct? And with these 7,000 users hitting my read-write workload, my batch request per second was approximately 3,000. Where did the rest of the users and rest of the requests go to? The secondary, the readable secondary, which is this next one. And in readable secondary, I had another 8,000 users connected, and they were firing read workload. Not so in the initial point, if you see the workload was not really great, but at the it's not working. At the later end, we'll see on an average for that time frame, we got 2,000 batch requests per second. Yes.
This assumes that application is flexible enough to separate that read and write, correct?
Application will not be flexible enough to do this, because if you know about always-on availability group configuration, we have to make some changes to the application, specifically in the connection string, using the read intent clause, where we have to tell the application to be redirected to the secondary workload. So they will hit the primary, and using the read routing that we configure on the AG configuration, they will automatically be redirected to the secondary. That's how we will have to do it. However, it's completely up to the vendor. And who's the vendor? The CRM vendor, right? I mean, end of the day, this was being done for that company. They can use the topology the way they want. They can directly just talk to secondary, right? I mean, for the read workload, completely up to them. Our job here was to just prove that SQL Server can scale out to this level. So we get this as with readable. Now, the main point here is 8,000 for primary, for 7,000 for primary and 8,000 for readable. Just a moment. Which means I had enough room. I had enough room to go even beyond it, right? I mean, beyond 20,000 users, I could have connected more users, but it just was not the need. Was sufficient to prove out that in this deployment, SQL Server can scale out to 15 to 20,000 users. Question? Yeah. What was that load balancer? Friends, there's no out-of-the-box load balancer. We did all this manually, right? So in the AG configuration, we will have to do this configuration of read intent, where the workload goes to primary replica, and using the connection string, it will automatically be redirected to the secondary, which means the connection string will say that I'm here only my intent. What does that read intent means? It means in the connection string, I'm only wanting to read. I don't want to write. And what will primary replica do? It will redirect that to the secondary replica. So out of the box, always-on availability groups do not offer any load balancing. It is we have to implement this, and that's what we did in this benchmarking and baselining activity. Yes?
What is the influence of delayed durability setting on a primary replica synchronous replicas? Do we do that?
Yes, I'll just come to that in a moment. A good question gets answered somewhere on the current slide. A great question gets answered in the next slide. Thank you for that question. So challenge number 5 was availability group latency, which is precisely your question. So friends, I don't want to shy away from admitting a fact that when we are benchmarking and baselining such massive deployments and talking about 15, 20,000 users, out of which 40% of users are reading and writing data, they're the right activity, there is going to be high latency, right? Because the data has to be in a synchronous commit mode, has to be shipped real time on the secondary replica. So we did see high latency, and a lot of these different techniques that can be implemented, get good faster drives for your log file, talking about log file performance improvement, or in availability group, there are certain configurations like not encrypting the data when you send it over the wire, because the primary and the secondary were sitting on the same data center. So it was really not using any public cloud. So you can turn off the encryption setting to improve the performance of data transfer between the primary and the secondary. And there comes another new feature in SQL Server 2014, which is delayed durability, which means when you commit your transaction, so when the transaction commit, typically SQL Server, like any other relational database platform, will follow ACID properties, right, for the durability factor, which means the data, the transaction has to be written in the log file before the commit goes to the client. But with delay durability setting, which if you turn on, your transaction is not going to be written immediately to the log file, but the user will get a commit acknowledgement, right? That can increase your log throughput. It can increase your transactional throughput dramatically, but there is a catch there, right? With delay durability turned on, you might have a chance of losing your transaction in case there is a crash, in case there is a failure of disks. You might lose some of those transactions that are not written onto the on the log file. So be very careful with this setting. Specifically in our situation with financial services institution, this will be a complete no-no. When we did this, there was no SQL Server 2014, and we just did not know even about this setting. But today also, even if I know about this configuration, I will never recommend this to this customer at least. The final outcome of this entire activity was we had a happy customer. And I'm very delighted to tell you all that this bank in India, one of the largest top 3 banks in India, is now using AlwaysOn availability groups as a scale-out deployment, as a scale-out model, exactly like what I showed you in this last 1 hour. So with this, am I doing good on time? Very well. I have 8 minutes. Just a quick summary: understanding the business IT need, setting up the configuration, generating test data. And when I say setup and configuration, consider everything: the hardware, the SQL Server configuration, max worker thread, etc., creating the workloads, performing the test, and then enjoying your result. Go for it. This is very challenging, as I said. There are not many people who are ready to jump from an airplane at 25,000 feet without parachute. And I agreed to do that, and it got me very good results. With this, so did you get a solid head start in benchmarking technique? All of you? Yeah? One of the collective objectives that we had here. So thank you very much. Please give your feedback. I know it's last day. You will be all ready to run home. But please give your feedback. It helps me improve wherever you think is necessary. And send your tweets at A_Bansal, MS Ignite, and MS_Ignite. And have a safe trip back home. Where is my plane? There is it. Yes. Thank you.